Good morning, sir.
Good morning, everyone. Only 14, 13 members are there. 14 members. 15.
Good morning, sir.
Hi, good morning. Shall I start the class?
Good morning, sir.
Pauli?
Sir, you can start the class.
Yeah, today we will discuss about detergent manufacturing. So, in the last class we have seen we know what is detergent. Detergent is nothing but a sodium or potassium salts of uh, long alkyl chain with a tail end of sulfonated compounds are there in the tail end. Okay, sodium or potassium salts of long alkyl chain with a tail end as sulfonated compounds like SO3H group, SO4 groups. Okay, These groups will be there in the tail end of the detergent. Okay, this is nothing but a definition of detergents. So how to prepare these detergents? Okay, popularly two types of detergents have been used. Like first one is sulfated fatty alcohol. Next one is alkyl aryl benzene sulfonates. Okay, alkyl aryl benzene sulfonates are commonly we can call alkyl aryl sulfonates. Okay, these two detergents are popularly used in the domestic as well as industrial purpose. The first one among those is sulfated fatty alcohols, and second one is alkyl aryl sulfonates or alkyl aryl benzene sulfonate we can call. Then how this first compound like sulfated fatty alcohol. Sulfated fatty alcohol is also a detergent. The name of this detergent is called sulfated fatty alcohols. You can just break and see fatty alcohol is one compound. After sulfonating this fatty alcohol, this is called sulfated fatty alcohol. Nothing but a composition of that particular detergent. Okay, how these detergents are prepared? Sulfated fatty alcohols are prepared. Okay, there are first we have to derive a fatty alcohols. Fatty alcohols are nothing but a high molecular weight alcohols. Okay, in order to derive these fatty alcohols, first we have to convert whatever the oil, whatever the triglyceride composition is there, we have to convert the triglyceride composition to this higher molecular weight fatty alcohols. Like the what are those fatty alcohols or the higher molecular weight alcohols? These fatty alcohols or higher molecular weight alcohols are nothing but the alcohols which are in the range of lauryl alcohol up to oleal alcohol. Like lauryl alcohol, we already know the formula C12H25OH. Then next one will come tridecyl alcohol will come something C13 carbons will be there, C13H25OH. The next in the series is myristyl alcohol. So it will have a 14 carbon atoms, C14H29OH. Then the next will be a pentadecyl alcohol. Pentadecyl alcohol, which means it will have a C15 carbon number 15, C15H31OH. Then cetyl alcohol will be there in the series. Cetyl alcohol, which will have a 16 carbon, 16 C16H33OH. Then next one is palmitoyl alcohol. Palmitoyl alcohol, it will have a 616. It will also have a C16 carbon atoms. So C16H33OH. Then heptadecyl alcohol will come in the series next. So C17H35OH. Then next one is stearyl alcohol. Stearyl alcohol, we already know it will contain C18 carbon, C18H37OH. Then the last one is this one, olyl alcohol, C18H35OH. Okay, these compounds, all these alcohols which now I have mentioned, I will mention one. Yeah. Uh, okay, the first one among those is lauryl alcohol, C12H25OH. Next one is tridecyl alcohol, which will have a formula of C13H25OH. Then the next one in the series is myristyl alcohol, C14H29OH. Then pentadecyl alcohol, which will have formula of C15H31OH. Then cetyl alcohol, it will have a molecular formula of C16H33OH. Then next one is palmitoyl alcohol, so C16H33OH. Then the next one will be heptadecyl alcohol and stearyl alcohol, which will have C18H37OH. Then the last one is olyl alcohol, C18H35OH. Around these 9 alcohols which I have discussed in this one, these 9 alcohols are the higher molecular weight alcohols which will be used in formation of this type of detergent, sulfated fatty alcohols. So how these fatty alcohols are prepared? So these fatty alcohols are prepared using by using sodium reduction or a potassium reduction we can call, or using a catalytic hydrogenation of coconut oil. Okay, as a triglyceride source. So here the coconut oil is the triglyceride source. This triglyceride source needs to be reduced using sodium or potassium. Okay, bandwidth, no bandwidth, same problem. Yeah, okay. There are two processes to just produce these fatty alcohols. First one is the sodium reduction or a potassium reduction. The next one is catalytic hydrogenation of coconut oil using some copper sulfate catalyst. Okay, copper salt catalyst. Okay, can be used to produce a fatty alcohols from the triglyceride source like coconut oil. So how these fatty alcohols are prepared? So first process in the process of this detergent manufacturing is first to prepare a fatty alcohols. How these are prepared? The first one is catalytic hydrogenation of coconut oil as a triglyceride source. So this catalytic hydrogenation will be carried out at high temperature around 200 to 300 degrees centigrade and high pressure around 100 to 200 atmospheric using copper salt as a catalyst. So this will be first process in preparing fatty. Okay, this one can be prepared using the first process, this one catalytic hydrogenation. The next process is the sodium reduction of coconut oil. Same, this coconut oil is used in this here. Here it is also coconut oil in the hydrogenation process, and as well as in the reduction process also coconut oil will be there. So the first reaction will takes place is some okay, in the sodium reduction of coconut oil, the first one is the first process is the preparation of molten salt. How this will be prepared? The raw materials required for this process is coconut oil. In the hydrogenation, hydrogen is required. Then next one is molten salt. Then oleum is required. Oleum is nothing but the sulfuric acid which is having a excess of sulfur trioxide composition is called a oleum. The next one is sodium hydroxide, NaOH we want. Then aliphatic solvent we want like toluene or xylene. The next one esterifying alcohol or emulsifying alcohol we can say like amyl alcohol. Okay, these are the required raw materials. Now how to prepare this molten salt? Molten salt, first we have to prepare it with a sodium metal. Sodium metal is just dissolved in some aliphatic solvent like toluene and xylene. Then it is also reacted with esterifying alcohol like amyl alcohol. Then the reaction between this amyl alcohol and molten salt will take place here as given in this reaction. This 11OH plus Na. This is C5H11OH is a amyl alcohol. This amyl alcohol will be okay. Then this is sodium. Yeah, this is sodium 2-methyl butyl 2-olate. This is called butane olate. This is called the reaction between amyl alcohol plus sodium will give a sodium 2-methyl butane 2-olate. It will give along with the liberation of active hydrogen. This active hydrogen will participate in the reaction with the triglyceride present in coconut oil. Then this the hydrogenation will take place. This triglyceride composition present in a coconut oil will undergo a hydrogenation process. This okay, then this hydrogen, whatever the active hydrogen is there, will undergo a reaction with this one triglyceride present in coconut oil. Then this will produce a hydrogenated fatty alcohols. These fatty alcohols after dehydration process will give you a fatty alcohols. Okay, this fatty alcohol with, along with the liberation of one glycerin molecule. This is glycerin. So now the reaction scheme we discussed. how the flow sheet will looks like, we'll discuss here. The first, what happens in the hydrogenation reactor, the catalytic hydrogenator. Here the catalytic hydrogenator will be there, in which a copper salt will act as a catalyst. At high temperature and pressure, hydrogen will be passed through this catalytic hydrogenator, through which coconut oil is fed to this hydrogenator. The temperature will be 200 to 300 degrees centigrade, and pressure will be 100 to 200 atmosphere. Fatty alcohols will undergo a sulfonation, okay, in order to give a tail end of sulfonated compounds in the tail end of detergent. So this is the next process. This is called a sodium reduction or potassium reduction process, in which what happens first, the molten salt will be added to the slowly to the coconut oil. The coconut oil is a triglyceride source here. The molten salts will be added here slowly to the coconut oil. Then whatever the reaction will take place, this reaction will take place. Okay, this reaction will take place, 6 hydrogens will be added, and the final fatty alcohols, higher molecular weight fatty alcohols will be liberated. These fatty alcohols will also liberated in this process also, in the hydrogenated process. Okay, whereas this is a completely hydrogenation process. There is no such a reaction, the sodium reduction. So this process is sodium reduction process. These reactions are for sodium reduction. Whereas this process at high temperature and pressure is called hydrogenated process. This one, this hydrogenated process. Then whatever the fatty alcohols form will just, the final composition will be just sent to one water tank. In this water tank, after some time, what will happen, there will be a 3-layer separation. Among that 3-layer separation, the first layer, the top layer is high molecular weight alcohols are formed. Okay, this is our product, main product, called a fatty alcohols. After sulfonation, we will get a detergent. Okay, this molecular weight, high molecular weight alcohols will be formed, and the middle layer will be regenerated, reducing alcohol, and the third layer and the bottom layer is called a caustic soda and glycerin. These two are for recovery. This is unconverted alcohol. This is a unconverted sodium, unused sodium, and liberated glycerin. These two layers needs to be separated in the water tank, and finally we want this high molecular weight layer. This high molecular weight alcohol, which is called a fatty acids, fatty acid alcohols, is sent to the sulfonation tower along with the fatty acid molecules which are liberated in the hydrogenated okay, as sulfonation will be carried out as given in this reaction. See here, whatever the fatty alcohols are there, this R1, R2, R3, in place of this R1, R2, R3, they have directly written only R. Okay, this fatty acid, this okay, volume is nothing but a sulfuric acid with excess of SO3 group, excess of SO3 molecules in it. So it will be reacted, fatty alcohol will react with a sulfuric acid. Then whatever the composition will be there, this fatty acid, sulfonated fatty compound will just undergo a reduction with this sodium hydroxide. Then the finally formed compound is called a sodium salt of sulfated fatty alcohols, nothing but a detergent. Okay, this is a sodium salt of sulfated fatty alcohol. This is nothing but a detergent. All this reaction will take place in this sulfonation. As we know, after this reaction, there will be certain impurities will be there. Those certain impurities will be just purified in a purification step. That is out of context for this for your syllabus. So, in as per the flow sheet, the first process to manufacture a fatty alcohols is the catalytic hydrogenation. In the catalytic hydrogenation, copper salt will be used as a catalyst at high temperature and pressure. The product from this hydrogenator is a high molecular weight molten salt, molten sodium, or a molten sodium dissolved in amyl alcohol and some aliphatic solvent like xylene and toluene will be added slowly. After the reaction, whatever the reaction mixture will be there will be poured into a water tank, in which there will be a 3-layer separation. Among them, the first layer and the top layer is the high molecular weight alcohol layer, which is a desired fatty alcohol for the sulfonation. Then the next one is And next third layer or the bottom layer is nothing but a caustic soda. Caustic soda, whatever the NaOH we use, along with the some glycerin liberated from this triglyceride composition like coconut oil. This high molecular weight alcohol layer, nothing but a fatty acid alcohols, and this high molecular weight, okay, will be sent to the sulfonation column, in which it will be sulfonated using this excess of SO3H groups, also known as oleum. Okay, also known as oleum. After sulfonation and reaction with NaOH, sodium hydroxide, the sodium salts of sulfated fatty alcohols will be obtained. That is nothing but a detergent. Okay. Any doubts are there in this one?
Sir, explain once again, sir.
Yeah. Okay. The first, according to the definition of detergent, what is the definition of detergent? Nothing but a sodium or potassium salts of long alkyl chain with a tail end having a sulfonated group. Okay, sulfonated group. That is nothing but a detergent definition. So this. Okay. Yeah. Sodium. See, sodium or potassium salts of alkyl chain, uh, long alkyl chain with a sulfonated group is called a detergent. So this you can see, this is alkyl chain and sulfonation. This is sulfonated tail and sodium salt, sodium or potassium salts. When this is K, we can call this a potassium salt. When this is Na, we can call this is sodium salt. The sodium salts of long chain, long alkyl chain with a sulfonated component, the tail end is called a detergent. So to manufacture this, first we want a alcohol, fatty alcohol. Okay, fatty alcohols we want. So fatty alcohols are nothing but a groups between lauryl alcohol to olyl alcohol. Okay, there will be 9 alcohols in between these two groups. So 9 alcohols, you can see that one. Then these 9 alcohols can be prepared using the source like coconut oil, triglyceride source like coconut oil. So how this can be prepared? Using the sodium reduction or a potassium reduction, or you can use a catalytic hydrogenator in order to give these fatty alcohol groups from the coconut oil. Okay, here coconut oil is a triglyceride source. From this triglyceride, we need to obtain a fatty alcohols. These fatty alcohols, lauryl to olyl group. So in order to obtain these fatty alcohols, we need to use this coconut oil either by catalytic hydrogenation or by sodium reduction process. We can obtain these fatty alcohols from the coconut oil. Then after obtaining this sulfonated, this fatty alcohols will be sulfonated using a oleum and then reduced using NaOH so that we can obtain a detergent. So in order to obtain this fatty alcohol for this first step, these two processes are there. The first process is the catalytic hydrogenation of coconut oil. So catalytic hydrogenation, how can we do the catalytic hydrogenation? At high temperature and pressure, like her temperature is 200 to 300 degrees centigrade and a pressure of 100 to 200 atmosphere. Using the copper catalyst, we can carry out the hydrogenation process. So after hydrogenation of this CH2OH, R2CH2OH, R3CH2OH. This is fatty acid alcohol. This is called. This can be obtained using this catalytic hydrogenation, or other process is called sodium reduction of coconut oil. So how this sodium reduction of coconut oil will be carried out? The first process, we have to do is preparation of this molten sodium. The molten sodium will be prepared by dissolving the sodium metal with some emulsifying alcohol like amyl alcohol with some aliphatic solvent like the hexane or xylene. Okay, xylene or toluene or hexane, whatever the aliphatic solvents are there, we can use the solvents along with the sodium metal and amyl alcohol and emulsifying alcohol, we can call. These three will be present as a mixture. These three mixture, the molten salt will be slowly added to the coconut oil in the reduction reactor. Then the reaction takes place. First, the reaction among this amyl alcohol and sodium will take place as given in this reaction. See, this is amyl alcohol C5H11OH plus Na, then reacted to give a sodium 2-methyl butane 2-olate. This is called sodium 2-methyl butane 2-olate. This is called C5H11ONa plus with liberation of active hydrogen. Then these active hydrogens will participate in the hydrogenation of this triglyceride. So this you can see 6 hydrogens, active hydrogens are added to this triglyceride present in coconut oil. Then whatever the component is obtained after the dehydration of this reaction, the fatty alcohols we can obtain along with the liberation of a glycerin. Okay, we know this triglyceride is nothing but a ester of 3 fatty acids with a 1 glycerin molecule. So here 3 fatty only to the coconut oil, the reaction takes place is this one. So this reaction will take place. Then after this reaction, whatever the reaction mixture will be there, will be poured into the water tank. In this water tank, what will happen after some time, after leaving this reactor for some time, then 3-layer separation will take place. In the 3-layer separation, the first layer is the high molecular weight alcohol. And then the second layer or the middle layer is the regenerated or reducing alcohol. Whatever the alcohols are there, unconverted alcohols are there, will be left in the bottom medium layer. Then the bottom layer is the caustic soda will be NaOH composition. Then the glycerin liberated in that reaction is just present as a bottom layer. Now our main product is this one, high molecular weight alcohol, nothing but a high molecular weight fatty alcohols. These fatty alcohols along with the fatty alcohols obtained in this first process called catalytic hydrogenation will be sent to this sulfonation tank. In this sulfonation tank, what will happen? The high molecular weight fatty alcohols will be reacted with a oleum together with a reduction using NaOH. So the reaction will take place as given in this reaction. See here, RCH2OH is the fatty alcohol. Fatty alcohol will react with one molecule of sodium, sulfuric acid or oleum. Oleum is nothing but a sulfuric acid only, but with the excess of SO3 groups. Excess of sulfur trioxide is called oleum. Then this fatty alcohol will react with the oleum along with the reduction using NaOH. Then finally we obtain a sodium salt of sulfated fatty alcohol. Here in the sulfonation, what will happen? Higher molecular weight fatty alcohols will be reacted to oleum and sodium hydroxide. So give a sodium salts of sulfated fatty alcohols. Nothing but a detergent. Okay. I hope you understood this one.
Yes, sir.
Yeah. Okay. Then the next one is the next one. This is also a detergent. So this is also popularly used detergent. It is known as ABS, popularly known as alkyl aryl benzene sulfonate. Aryl benzene sulfonate we can call. Alkyl aryl sulfonates first one. How this alkyl aryl sulfonates will be prepared? We have to discuss this one. So alkyl aryl sulfonate we can prepare using the okay, we can obtain the paraffins from the kerosene. Okay, this is the cheaply available petroleum feedstocks in order to prepare a detergent. So how this detergents will be prepared from the kerosene? So whatever the kerosene compositions will be there will be fractionated. Okay, fractionated using the molecular sieves as an adsorbent. Molecular sieves are nothing but a zeolites with some controlled pore size and controlled surface area. As you can see from this picture, this is nothing but a molecular sieves. These molecular sieves will be used in the fractionation of this kerosene as a raw material. Now this kerosene, after fractionation of this kerosene, the role of molecular sieves is to adsorb the paraffins. Okay, and paraffins. After fractionation of this kerosene composition, the isoparaffins or a branched chain paraffins and a normal paraffins, these 3 paraffins will be formed. Okay, among these 3 paraffins, the paraffins or a normal paraffins we can say, normal paraffins are nothing but a biodegradable compounds. So according to the environmental norms, whatever the detergent industry is preparing, the detergents needs to be biodegradable in nature. Otherwise, if they are not biodegradable in nature, we can't liberate to the outside environment. Okay, they will not biodegradable, then we will have a some huge impact on the surrounding environment. So according to the norms, we have to prepare only the biodegradable compounds for the detergent. So in order to prepare paraffins, normal paraffins are the only sources to obtain a biodegradable detergents. So we need to prepare this biodegradable detergents using only normal paraffins. So after fractionation, whatever the fractionation will take place, a distillation process, heating process. Okay, after heating this kerosene, after fractionating this kerosene, we can obtain the three types of compound. One is normal paraffin, next one is isoparaffin, or we can say the branched paraffin. Out of these three compounds, we have to separate only the normal paraffins. How this normal paraffins will be separated? Using this molecular sieves as an adsorbent. In this molecular sieves, what will happen? This molecular sieves will preferentially adsorb only this normal paraffins, and it will just retain isoparaffins or branched paraffins on the outside of this molecular sieves. Then whatever the adsorbed normal paraffins will be there will be dissolved using certain solvents. Adsorption is nothing but attaching to the surface. Desorption is nothing but releasing from the surface. The first step is attaching the normal paraffins to this molecular sieves. The next step is desorption, or taking out that normal paraffins outside of this molecular sieves. Then that normal paraffins will be used to chlorinate. Then after chlorination, the alkyl chloride we can obtain along with the hydrochloric acid, one molecule of hydrochloric acid. Then this alkyl chloride will be used to use it for the reaction between a benzene. Then whatever the AlCl3 will be released, this ABS will be formed. ABS is nothing but aryl benzyne sulfonate after reduction with the oleum or a excess of sulfuric acid. This is sulfuric acid. When we use the excess of SO3, this is called a oleum. This compound is there. Whatever the aryl benzene compound is there, this compound when sulfonated, this will give you aryl benzene sulfonate. Okay, the first process is the raw material is the kerosene. When kerosene is fractionated or heated or distillated, okay, this will release three types of compounds. One is the normal paraffin, the second one is isoparaffin, third one is some branched paraffin. Out of these three paraffins, normal paraffins are the biodegradable in nature. So we have to use these normal paraffins in our detergent manufacturing. So in order to separate this, the role of this molecular sieve is to preferentially adsorb the normal paraffins into it and leave the isoparaffins and branched paraffins outside this layer. Or we will just separate that attached normal paraffins outside. We will bring that attached normal paraffins to the outside of this molecular sieves. Then these normal paraffins will be chlorinated. Yeah, okay. Then this alkyl chloride, whatever the alkyl chloride is there, will be reacted with the benzene to give you this aryl benzene compound. This aryl benzene component, when sulfonated using a oleum is nothing but a component, sulfuric acid, which is having excess of sulfur trioxide into it. So when sulfonating this aryl benzene compound with this oleum, after sulfonation we will obtain the aryl benzene sulfur. This is called a detergent. Okay, I hope this you understood.
Yes, sir.
Yeah, only reactions is there for the aryl benzene sulfonate as per your textbook. So you examination, and this one also only reactions are given, but this process I just prepared this flow sheet by this explanation. You can go through this one. Yeah, okay, this unit 2, from this unit 2 is completed. I will share whatever the PPT is there. I already given a notes, uploaded the notes, and also shared in your WhatsApp also. So now I will just share this PPT. You want me to share through WhatsApp or this Microsoft Teams? Pavani?
Sir,
Uh,
send in WhatsApp and also in
WhatsApp,
my.
Teams or
Sir, in Teams, it will be easy
WhatsApp?
for us to keep everything in
రవి
one
టీమ్స్
place.
అందరికి ఓపెన్ అవట్లేరా ఫోన్ లో.
అందరికి ఓపెన్ అవ్వటం లేదంట.
నాకు ఓపెన్ అవట్లే, అప్పటి నుంచి ఓపెన్ అవట్లే టీమ్స్ లో.
Okay, no problem. I will share in WhatsApp at the same time Teams also.
ఎస్ సార్, ఎస్ సార్.
In the Teams I will upload later. I will just I'm just sending through WhatsApp now. I already sent that one. Okay, along with this CT2 old question papers also, one PDF file I just okay, I sent you through the WhatsApp. Confirm me, have you received it one?
ఎస్ సార్.
Yeah, okay. My internet connection is very slow. It is not showing me that you have received that files. Okay, then I will just quickly revise this unit 2. Otherwise, if you have any doubt, you can ask me. Shall I revise or you can ask me any doubt? Hello.
Sir, revise. Sir.
Okay. Yeah, the first this unit 2 is regarding the oils, soaps, glycerin, detergents. Okay, there is how these oils are prepared. First, we have to see how these oils are prepared. Then the next one is how these oils are stored for the long shelf life, like hydrogenation. We have to break this double bond so that its reactivity will be reduced, and at the same time, its shelf life will be increased. So the first one is the preparation of oil or the extraction of oil from the oil seeds is the first process you have to see. Then the next one is the hydrogenation of that oil. Whatever the oil we obtain, we obtain our oil at different conditions. Like somebody will obtain oil using cold press, somebody will obtain oil using some solvent extraction, somebody will obtain oil using the hot press. Okay, out of this, some of the compounds generated may be the unsaturated fatty acids. So these unsaturated fatty acids will have a high reactivity. So then this reacts at high rates. What will happen? Rancidity will happen. Rancidity is nothing but a production of off flavors. Okay, off flavors of the off flavors are nothing but we can call a bad odor. Bad odor will come due to the oxidation of that particular oil. So in order to lower this rancidity, we need to hydrogenate that oil. So next flow sheet will be hydrogenation of that oil. Then the next one is the essential oils. It's a small part for you. Essential oils. You can go through this one. Essential oils are just types of essential oils. They are asking. Then the next part will be preparation of soap. The major consumer of oil industry is nothing but a soap industry or a detergent industry. Whatever the oil we prepare will go to the soaps. So how these soaps are manufactured? There are two processes to manufacture the soap. The first one is the batch process, and the next one is the continuous process. In the batch process, we can see what we call direct. We have seen the hydrolysis first and then sulfonation. So the first flow sheet in the saponification process or nothing but overall third flow sheet in this unit is soap preparation. In this soap preparation, we can prepare the glycerin. Okay, glycerin is the byproduct in the soap preparation process. In the third flow sheet itself, you can see the natural glycerin preparation process. Then the next one is the is also used the oil as the triglyceride source in order to obtain the detergent. So out of this unit, only 4 flow sheets are there for you. Okay, the first one is the extraction of oil flow sheet. The next one is hydrogenation of oil flow sheet. Then the third one is the flow sheet of soap and natural glycerin manufacturing. and fourth one is the detergent manufacturing. Okay, these four flow sheets are there. Okay, then the part 2, part A already we discussed in the syllabus. So same one. So what is the oil? Oil is nothing but a which feels like a greasy compound. Okay, when we just retain on our hand, it will feel like a some greasy compound or oily compound. As per the scientific norms, it is nothing but a hydrophobic nature, which will process the hydrophobic nature, nothing but a immiscible with water. At the same time, it will be a lipophilic compound. Lipophilic compound is nothing but mixture of it can mingle with other type of oils, is known as a lipophilic property. So oil is as per the industrial terminology, oil is nothing but the compound which possesses hydrophobic properties as well as the lipophilic property is called a oil. So oil, we know it is a non-polar Okay, so oil is not visible with water, so they are called non-polar substances. Then oil may be anything ranging from the cooking oil to the crude oil. Okay, cooking oil may be used for the nutrition purpose or the soap or detergent preparation purpose. Okay, crude oil is used for petrochemical preparation purpose, for the lubricating purpose, from the cooking oil to the crude oil. So this crude oil is also known as a oil as per the definition. Then there are many types of oils. Okay, what are these types of oils? Okay, they are classified according to their origin, like whether it may be a plant origin, whether it may be an animal origin. Okay, from this the major distinction is whether it may be a plant origin or it may be animal origin. All these are the examples for the oils. General oil, plant origin oils, edible, it may be non-edible, and animal oils or microbial oils, petrochemical oils, or volatile essential oils. These are all the examples for the oils. Then what is edible oil? Edible oil is nothing but compounds which we are used for our nutrition purpose or for our eating purpose or for our cooking purpose is known as a edible oil. Whatever we are using in our household purpose is classified under the edible oils. There are also two types of sources for this edible oils. The first one among is the plant origin oils. Plant origin oils we largely consume in a household purpose, like a palm oil, olive oil, soybean oil, canola oil, pumpkin seed oil, corn oil, sunflower oil, okay, peanut oil. These are all the examples of edible oils which we are consuming in our day-to-day daily life. Then the next source is the animal origin or the microbial origin source, like the fish oil and microbial oil. Fish oil nowadays for the supplements like omega-3 fatty acids. Okay, in order to take this as a supplement, these tablets, the yellowish tablets which are shown here, is nothing but a fish oil which is obtained from the fish as a source. Okay, this type of oils are also as edible oils, so we are consuming as a supplements here. These are also forms under the edible oil sources. Then the next one is non-edible oil sources. Non-edible oil source, like the edible oil source which are used for the cooking purpose or the nutrition purpose, eating purpose, is called edible oils. Whichever not used for the food purposes are called a non-edible oils. Like the example, these are also having a two types of origin sources. First one is the plant origin, the next one is the animal origin. Plant origin sources is nothing but a which are obtained from the plant sources, like this mahua plant. The mahua seeds after drying will look like this one. Then the karanja oil, the karanja seeds and the plant will look like this one. After drying, the seeds will look like this one. Then polanga oil, the seeds will look like after the separation of the dehulling process, it will look like this one. Then next one is the neem oil. Then the seeds obtained from the neem oil will look like this one. Then rubber seed oil, the seeds after drying will look like this one. Then jethro oil, the plant will look like this one, and this after drying the seeds will look like this one. All these seeds are nothing but a plant origin non-edible oil sources. So with these oils we cannot use for our cooking purpose or our food consumption purpose. So therefore we can use for some other purposes. Then in the non-edible oil sources there are another origin sources like animal or microbial oil sources. So the tallow or a cow fat, okay, the chicken fat, these are all or a non-edible oils. They can be used for other purposes like biofuel synthesis purposes, whereas we can't use this for the edible purposes or eating purpose. Then next one is the essential oils. Essential oils is nothing but a odoriferous oils. Okay, these odors are nothing but a pleasant, which we can feel it as a pleasant, not a bad odor. This is called a pleasantly odoriferous oils. These are popularly used in soap manufacturing, medicine manufacturing, cosmetic manufacturing industry. So examples of this type of oils are nothing but first one is lemon oil. We trigger. The next one is cinnamon oil. This cinnamon, using this cinnamon, you can obtain this oil using certain process. Then lemongrass oil. This lemongrass, as you can see from this picture, this lemongrass can be used to obtain an oil. Then clary sage oil. This sage plant will be there. This sage flower will be used to obtain this clary sage oil. Then lavender oil. Lavender plant will be used to obtain the lavender oil. Then the tree tea oil. Whatever the tea we are taking, the tree will be there. That tree will can be used to obtain the oil. Then eucalyptus oil, you can see the eucalyptus plants can be used to obtain the oil. Then rosemary oil. This is the rosemary plants, we can obtain rosemary oil. Then the sweet orange oil, from the oranges also we can obtain the oil. Then peppermint oil. Okay, this is popularly used in cosmetics. This is also obtained using the peppermint. These oils, all these oils are nothing but essential oils. This doesn't mean that our body needs these essential oils very much. These are used as per the industrial terminology. These are used for the pleasant odors, pleasant odors or the pleasant smells. For the fragrance, we can use these oils. Therefore, these oils are known as the essential oils. Then the fats. Fats are also having the same composition as that of oils, but they are differ in such a way that they are solids at room temperature, whereas oils are liquids at room temperature. As per the terminology of industry, fats are also having the same chemical structure and composition as that of oils, but they are solids at room temperature, whereas oils are uh, liquids at room temperature. Then the chemical composition and physical properties of fats and oils. Okay, chemical composition of a oil or a fat is nothing but a oil and fat is composed of a triglyceride composition. Largely, any type of oil will be composed of a triglyceride. As you can see, the structure in the right side, this is the triglyceride. This is the major composition of any type of oil. So how this triglyceride will look like? This triglyceride is nothing but a ester of 3 fatty acids and 1 glyceryl backbone. Is nothing but a triglyceride. This triglyceride will form a major composition in any type of oil. So this triglyceride, the number of double bonds in the fatty acid radical. This fatty acid radical, out of this radical R1, R2, R3, whatever this radical is there, number of double bonds in that radical will define that a particular fatty acid is a saturated fatty acids or it is a unsaturated fatty acids. Now, what happens with the unsaturation? Unsaturation is nothing but presence of a double bond. Then how this presence of double bond will influence the melting point at the same time of reactivity? Because you can see from this table, the stearic acid, which is a saturated double bond. Okay, there is zero double bond. So there is no double bond issue here. So its melting point is very high. So its reactivity with oxygen is very low. Nothing. There is no reactivity with oxygen. So this stearic acid compound will have a long shelf life because it couldn't react with surrounding oxygen. So we can store this stearic acid for a long time compared to this oleic, linoleic, and linoleic acid. As you can see, this oleic acid will have is a unsaturated, have at least one double bond. This one double bond, how this one double bond point of saturated fatty acid is 69, whereas the unsaturated with a one double bond is 14. So it will lower the saturation. The unsaturation will lower the melting point. At the same time, it will rise the reactivity. So here you can see there is no reactivity in the stearic acid, whereas there is a fair reactivity in the oleic acid. So since these are reacting with the oxygen, so its shelf life will be very less. We can't store more for a more time this oleic acid. Like in the linoleic acid, this also a unsaturated one double bonds. See, there are two double bonds in this linoleic acid, and linoleic acid will have three double bonds. How this influenced in the melting point? See, this melting point is drastically reduced. Because of this, the reactivity will be extremely very high in the linoleic acid case. When reactivity is very high, it will be degraded easily. That oil will degrade easily. Then how to stop this? Okay. There are two processes to stop this reactivity of the fatty acid group. So how this reactivity will be stopped? By the conversion of these unsaturated fatty acids to the saturated fatty acids. The conversion of unsaturated to saturated fatty acids is nothing but removal of double bond. So how we can remove this double bond? So first one is C, hydrogenation. We can remove the double bond using the hydrogenation. The next process is some antioxidant compounds. Antioxidant compounds can be added to this oil composition so that it will resist the oxidation process. That oxidation process, when it resists, it will cannot be degraded. So to stop the reactivity, there are two types of process. The first one is the hydrogenation process. It will remove the double bond. The next one is adding some antioxidant. So hydrogenation process, we will see what is the rancidity. Is the process of complete or incomplete oxidation or hydrolysis of a fat and oil when exposed to air, light or moisture by bacterial action, resulting in the unpleasant taste and odor. So a rancidity is nothing but reaction with the surrounding environment, so that it will degrade that oil. So out of this degradation, the unpleasant taste we will obtain, and at the same time unpleasant odor will be obtained. So it is non-desirous for the food purpose or a cooking purpose, for any other applicable purpose. So we need to stop this rancidity. How can we stop this rancidity? We can stop this rancidity in two ways. One is using hydrogenation process, which will remove the double bond, and other one is using the antioxidants, so that it will resist the oxidation process. So how this rancidity will act? So when hydrolysis or oxidation of fat is taking place, the compounds which generated is nothing but a aldehydes and ketones. These aldehydes and ketones are responsible for this unpleasant taste and okay, these aldehydes and ketones are mainly responsible for producing the unpleasant odors and flavors. So as per the industrial terminology, oils are nothing but liquids and fats are nothing but solids at normal or room temperature. So what are the uses of these oils and fats? The uses of these oils and fats are nothing but first one is the food purpose. We can use daily day-to-day life. We are using the, for the nutrition and food purpose. These oils that we are using, and soaps and detergent manufacturing industries are the major consumers of these oils. Then paints and varnishes. Yeah, then in the cosmetic industries also we can use these oils and fats. Then at the same time, medicinal purposes, many essential oils are used in the medicines also. So all these are uses for the oils and fats. We can oil biodiesel as also a industry which uses the oils and fats. Okay, the next one is the flow sheet, which is the method of preparation of oil or extraction of oil from the seeds. Okay, there are two processes for extraction of oil. So one is the mechanical extraction process using some continuous screw extruder or expeller, or using some batch hydraulic press. And the next one is solvent extraction process. So for the raw materials required for this extraction process, the seeds we need to require, whatever the oils we are going to collect, those seeds we have to store as a raw material. The next one is a solvent, like a petroleum cut, like a hexane fractions, which are flammable. The next one is a trichlorohexane. We can use it as a solvents in the extraction process. Then purification, like a purification, neutralization oils, like neutralization agents like NaOH and NaCO3. And next one is the bleaching agents, or some color removal agents like a fluorescent and carbons we can use. Then the process will take place in such a way. First, the seeds will be there. It will be separated from the outer shell, or nothing but a dehulling process. The seeds will be dehulled and cleaned. Then it will be cooked at a temperature of 220 to 250 degrees centigrade. Then it will be pressed. Whatever the oil will be there will be released out from that interstices of the seeds. Then that oil, then whatever the oil cake will be obtained, we can feed it to the animals, or we can use that, we can send that to the solvent extraction plant.
when the solvent extraction plant, whatever the solvent will be there, will just impinges into that seeds, that cake. Then that will just solubilize whatever the oil present in that seeds. Is the role played by this solvent. The solvent role is such a way that it will impinges into that seed cake. Then whatever the oil present in that seed cake will be extracted from that seed cake. That is the role played by the solvents, like a petroleum products like hexane, heptane, propane we can use, trichloroethane ethylene we can use. Then after obtaining this oil, whatever the odors are there, whatever the acidic compositions are there, will be neutralized. Whatever the odor or whatever the extra coloring components are there, will be just purified. This is nothing but purification process. There are four major steps in preparation of this extraction of oil: pressing, then solvent extraction or purification. So this is the overall go through this flow sheet. Then hydrogenation of oil. Then why we have to use the hydrogenation of oil? Because to convert the unsaturated fatty acid to the saturated fatty acid. Nothing but a conversion of a double bond to a single bond to the saturation, which is nothing but hydrogenation of oil. Hydrogenation of oil is done to raise the melting point and also to increase the resistance to rancid oxidation. So rancidity is nothing. It will be produced off flavors. So in order to reduce the degradation, we need to do the hydrogenation of oils or fats. So hydrogenation of oil is also known as a hardening of oil. Okay, the raw materials required for hydrogenation is oil, purified hydrogen, bleaching or adsorbent agents to remove the coloring compounds are called Fuller's earth carbon. Then we required some of the vitamins we can add to this one. Then the end products for this hydrogenation of oil is vanaspati, dalda we can say. Then a solidified household oil for cooking, dalda we can say. Then vegetable ghee also we can obtain. The hardened industrial oils, many oils can be obtained. Partially hydrogenated liquid oils we can obtain. These are the end products of the hydrogenation process or hardening of oil process. The reaction is nothing but addition of hydrogen to the whatever the triglyceride molecule will be there, to which the hydrogenation will hydrogenation will be added. Hydrogen will be added. The catalyst will be a Rani nickel. Okay, Ni star is nothing but okay. We can prepare the nickel in these three steps. Okay, out of this three steps, this Rani nickel will have a high surface area. It will looks with a much porous structure. So this is called a Rani or spongy nickel. This nickel will be a very much advanced process. So it will look like this one in a gray color. This is the flow sheet for the hydrogenation process. The high temperature pressure used for the hydrogenation of oil. Then it will be a corresponding purification process. This one. We can watch the previous sessions. Major engineering problems out of this is the thermodynamics and kinetic problem. Since this reaction is the exothermic reaction, slightly exothermic reaction, so we need to maintain some coolant around this hydrogenated reactor in order to maintain the reaction temperature accurately. So this is the thermodynamic problem, and next one is the kinetic problem. So hydrogenation steam. In the hydrogenation process, there are different rate controlling mechanisms. So these rate controlling mechanisms can be depends on this diffusion and surface reactions also, and also in the desorption. So how these different mechanisms, different rate controlling steps will be involved, you can see in the detailed mechanism. When the temperature of this reaction is around 100 degrees centigrade, 100 degrees centigrade, the surface reaction and the adsorption, these two steps, 1 and 4, at the same time, this not 1 and 4, this one chemisorption 3 and this 5, 3 and 5 and 6 will play a rate controlling step. And next one is the rates when the temperature is around 180 degrees centigrade, then the adsorption 1, 4, 7, 8 along with this diffusion rates will be a controlling steps. So how the temperature will influence the controlling rate will have a large part of this hydrogenation influence on the hydrogenation process. These are the major engineering problems. The next one is the handling of H2, hydrogen. We already know At high pressures, it will impinges into the lattice structure of the steel or a construction equipment of the construction material of the reactor. So it will produce a hydrogen embrittlement. So it will produce a hydrogen embrittlement. It will break that reactor composition, reactor components. So this is what for today. I think our time completed. I will download attendance. In the next class, we will continue that one, the discussion of part B.